So when one event does not affect the occurrence of another event, like the coins here. The first coin did not care. The second coin did not care what the first coin's doing. They're totally independent. How about this situation? So write this down. Here's my bag of marbles. Okay. They have 4 blue, 3 green, 2 red, for a total of 9 marbles. Okay. So let's say I stick my hand in the bag. I grab. Let's see if I can grab one here. Let's make it 5 blue. If I grab 1 marble and I keep it, so let me put the marble back in. What's the probability of me grabbing a blue marble? That would be what? 5 out of what? 10. So watch me. If I grab the blue marble, and then, look at this, and what if I grab the green marble? No, what's the probability of me grabbing a green marble now? It would be 3 out of what? 4. Right, this is out here. So look at, the sample space is now shrunk. So the probability of me, look at the probability of me getting a blue and then a green right after, these are what we call dependent events, because me getting the blue marble first shrunk the sample space from 10 to 9. So me getting the green depends upon me getting the blue. Or another way to say it, me getting the blue affects me getting the green, because the sample space is now changed. It affects the probability. That's dependent events. This depends on this to a certain degree, because it went from 10 to 9. The number of marbles went from 10 to 9, the sample space shrunk. So let's go back up there and define dependent events. We'll write this. When one event affects the occurrence of another event. When one event affects the occurrence of another event. So on the independent events, go to put, right here, just go to put EX for an example, just to remind yourself for the test tomorrow.
Isn't it effects or effects?
Right, A, with an F, with an A.
What about the S or the S?
When one event affects, good looking up, the occurrence of another event. So for independent, going to put flipping 2 coins. Just so you have a small example to remind you. For dependent event, put grabbing a marble without replacement. Remember that blue marble? I didn't replace it. I didn't put it back in the bag.
You write that?
Right. This is a small example. Put EX for, this is dependent event. Grabbing a marble without replacement. That's the key word here. You're going to see this on your assignment 28 later. The words without replacement are like the signal that you're dealing with dependent events. Grabbing a marble without replacement. And then grabbing a second marble. Yes.
Also extend.
The man break up. We'll do 2 quick examples and we'll be done. till tomorrow, and we're done. It's not the most favorite of topics. It's huge though. Probability is enormous. Some of you are going to try to pass your DMB test. You guys are at that age group where you're doing that in the written test, in your permit. When you walk into an insurance office, car insurance, that whole industry is based on probability. It's because knuckleheads your age are always getting crashes and driving as DUIs, being stupid. It drives your rates up. It's because of probability. So probability is going to affect you very soon when you try to get your car and insure it in a big way. You'll see what I'm saying? It is, and it's expensive because of probabilities. They keep records of crashes, DUIs, tickets, citations, and your age group, if you're in a graph, your age group gets the most. In other words, you being your age, there's a high probability that you're going to get in a crash. Therefore, the insurance company wants more money from you each month in case you do get in a crash.
That's unfair.
To who? You or the insurance company?
I think it's unfair for the insurance company to do that.
Well, that-
Generalizing.
Wait, if I'm an insurance company, I'm offering you a service. And if I offer you a service and I'm trying to make money because I'm in a business, how is that unfair that you're in an age group that typically gets, you're giving me money for a service? You got to rethink what you're saying. What do you?
You don't have to be 18 and insure your car from name rate.
I don't think so.
I think you do. Or 17 and a half. I think
Is it?
Yeah.
But your parents can put you under insurance with a permit.
That's what I'm saying.
Yeah, so yeah. All right, so probability is going to affect you big time. Let's do one example. Actually, two. Two quick examples. Here we go.
Right, then?
If you understand. You're not doing anything yet.
I mean, but no.
All right, here we go.
I'm a licensed driving car.
What do we write them?
You having a license scares me.
What?
There we go. All right, up the bottom, go to write example one.
Bottom where it says no.
Yes. Go to write, what is the probability of getting a heads and a heads 2 times in a row? Flipping a coin.
I mean, there's only one way of getting that, so like 1 out of 100. I mean, 1 out of 50.
It's negative 25%.
1 out of 20.
No, it's still 50-50, isn't it?
Okay, let's see. Let's see. Here we go. So I'm going to flip the coin twice. What's the probability of me getting heads and then the heads again right after it?
50.
Before I answer that, thank you. Watch this. I'm going to come back to you. Does the second time I flip the coin, does it care what it landed the first time?
No.
No. So will these be independent or dependent?
Independent.
Independent or dependent?
I mean, independent.
Right. They're totally separate. Right. The first coin's flip and landing has no effect, no influence upon the second time the coin flips. The coin doesn't care what had happened before. So these are independent events. Look at the bottom of your paper there, or in the midsection. You have the formula for independent events. The probability of A and B, it says, look at the formula there, right in the middle, is equal to, watch this, the probability of A happening times the probability of B happening. This is for independent events. It even says it right there in your note guide. So let's do it. Let's plug in should. The probability then, my A would be my heads. Of heads and heads. My B would be another heads. Again, I'm just following the formula. What's the probability of A of me getting a heads? Just with one coin toss. 50-50. But what in a fraction form? 1/2, huh? 1 out of 2 sides, huh? That's the probability of A. That's the probability of getting the heads. I'm just following the formula. Times, all right, what's the probability of me getting the heads the second time? Just right here. 1/2 again. Do you remember from junior high school how they taught you how to multiply by fractions? Hit it, Jovanovic.
One time it goes split multiply times.
Do you mean across this way, or do you mean across numerator times numerator?
Cross
Numerator to
multiply.
numerator.
See, the thing is, the word cross can mean down, or it can mean that way.
Oh, no,
It's one times one and two times two.
Right, right. So numerator times numerator, denominator times denominator. So here we go. So the probability of me getting two heads in a row, check this out, is what? 1 out of 4, huh? Which is, in decimal form, 0.25, 25% chance.
I was thinking because they're independent. I was thinking that way because they're independent.
This should ring a bell from warm-up. Remember warm-up? Look what I did on warm-up. Look at it. There's your 4 possibilities. Where was the heads and heads? Right here. 1 out of 4. Right there for you to see. You just were not aware of it. So we did an independent event for warm-up. One more. Last one for now. Example 2. What is the probability of getting a jack in a deck of cards and then rolling your favorite number? Rodriguez. Just make one up. With 1 dice up. Pick a number between 1 and 6. Pick a number between 1 and 6. Yeah, pick a number between 1 and 6. Watch this. What's the probability of getting a jack from a deck of 52 and then rolling a 2 with the dice? So I got a deck of cards in my hand, or actually on the table. I got one die in my left hand. Would these be independent or dependent? So the dice does care whether I got a jack, if I got a jack. The dice is thinking that. Oh, I better land a 5 because he got a 9. They're independent, huh? So this has no effect on this and vice versa. Independent. Dice do not care what happens outside of you throwing it. I don't even think they care if you do throw it. Do you think it hurts the dice's feelings when you throw it? Like harder?
Because it wants to be thrown. What if it's instead of those?
I know. You're right. So it doesn't care. So watch this.
Generalizing dice.
Stereotyping dice. The probability of getting a jack and a 2, here we go, is the probability of getting a jack times the probability of getting a 2. Simple as that. Notice I separate them and I'm just going to multiply them each. They're independent. Again, I'm just following the independent formula. I'm following the formula in the middle of your paper. Probability of A and B is equal to probability of A times probability of B. A here just means a jack. B means getting a 2 and off the die. Question so far? Do it. So, the probability of getting a jack. How many jacks in the deck?
452.
4. There's 4. Let's see. Where's the jacks? Here they are. The jacks. There's 4 of them. 1 in each suit. 4 of diamonds, 4 of spades, 4 or jack of hearts, jack of clubs. These are spades, hard to see. Spades, hearts, clubs, diamonds. 4 jacks in the deck. Here we go. So 4 out of 52 here times 1 over 6. One die has one side that's a 2 out of 6 sides. We're rocking and rolling. Question so far?
We get 1 over 6.
Because think of a die, right? There's 6 sides, 2 die. Let's see. A die. There we are. Look at the 6 sides. And only one of them's a 2.
6, 5, 4.
She's got a spooky voice, huh? She's got a spooky voice.
Sure.
Let's do it.
Can you watch it outside for a second?
One more time. Got you. 4 times 1's 4. Yay. 52 times 6. Help somebody. What? Decimal time. 4 divided by 312? 0. What? Help. 0.12? Thank you. We're going to round to the nearest hundredth like I told you in warm-up. The nearest hundredth is at 1. So it's about a 1% chance. It's a hundredth place. It's a 1% chance for you to get a jack and then roll a 2. It'll happen on average once every 100 tries. If you try it 100 times, it'll probably happen once. So that's what 1% means. All right, let's watch some Lionel Messi. While I have the game on, you're working on 24, 25, or 23 from yesterday. I'll be calling you one at a time to show you current grades. Any questions for example 2? Hit it. You may. Get out of here.
I'll be right back. There's
You're the man.
I don't know.